So remember, I suggested that Chapter 6 was split into two parts. So we just finished the first part, which was to learn how to factor algebraic expressions, binomials, trinomials, polynomials with four terms, get the greatest common factor out, etc. What we're getting ready to do now is to work with algebraic fractions. Algebraic fractions and write equivalent expressions. So we are going to simplify fractions. So I'm going to come on over here. We are going to simplify or reduce fractions. We are going to multiply and divide fractions. We are going to add and subtract fractions. We are going to work with applications, some health applications, some false positive and false negative cancer tests for patients. We are going to solve equations that involve fractions. So there's only 4 sections left, sections 5, 6, 7, and 8. But all this is going to be about algebraic fractions. And it's particularly important in mathematics, later in the study of calculus, but also in the sciences where we have to simplify algebraic expressions or rational expressions. So I'm going to share with you the processes. So really bold here. When you simplify algebraic expressions, and for that matter, when you multiply and divide, you must factor everything first. Now, the first question doesn't really have any factoring to do. I mean, you could write the numerator as 7 times A times A times A, and you could write the 21 as 7 times 3 times A. That would be what we call factoring. And what you're going to do is you're going to remove common factors. So 7 over 7 is equal to 1, and A over A is equal to 1. And so you have reduced this fraction, and upstairs you have left A squared, and downstairs you have a 3. Well, I could have done this way back here. I could have said 7 goes into here once, into here 3 times. And then I could have said, oh, when I divide, I subtract their exponents, and a to the third over a to the first is a to the second. So I could have done that without factoring. While we're there, let's look at number 3. So just go ahead and reduce the 9 goes into here once, into here 4 times, and then x to the second divided by x to the first. Remember, that's a 1. You subtract the exponents. 2 minus 1 is 1. So you have either 1/4 x, or we can write that as x over 4. All right, let's go back to number 2. So the process says, way up here in bold, factor everything first. So while I can think of the 21 as 7 times 3, and I can go ahead and write that down, it's not necessary that I do that. But this binomial has a greatest common factor in it. And the common factor is the number 3 can come out of each of those. So I'll need a 2x here so that this 3 times 2x is a 6x. And I'll need a minus 3 right here. And now, as a result, I can remove common factors because when I take the 3 out of this, I have removed something that's called 1. And so I've reduced that fraction. So upstairs I have a 7, and downstairs I have a 2x minus 3. I'm all done. Let's do this again in number 4. So let's look always for the greatest common factor first. So in number 4, these two have a 3 that can be factored out. And you would need an x plus 7 here then. Downstairs, they share a common factor of the letter x. And when I factor that out, I'll need an x plus 7 here as well. So sometimes the common factor that I remove is a binomial factor. So x plus 7 over x plus 7 is equal to 1. So I can remove that common factor of 1, and what I have left is 3 over x. Now here's what I want you to do. If we were in a regular classroom, I'd say, hey, somebody pick a number for x. So I'm just going to pick 5. It just came to my head. So I'm going to take the original expression, and I'm going to put a 5 in here and anywhere I see x. So I'll have 3 times 5 plus 21 in the numerator. And downstairs, I'll have 5 squared plus 7 times 5. So upstairs, 15 plus 21 is 36. And then downstairs, 5 squared is 25, plus 35 is 60. that fraction can be reduced. I think 12 goes into here 3 times and into here 5 times. So that fraction can be reduced to 3 over 5 in the end. Now, my finished answer to this problem was 3 over x. Remember, I said x is equal to 5, and I should get the same value, in this case 3 over 5, whether I put the 5 in the original expression or I put it in the ending expression. But believe you me, it is way easier to put the 5 in here than to go through all this work and get 36 over 60 and have to reduce it down to 305. So I hope you can see the value in this, and there will be a lot of science applications here. So number 5, I'm going to look and see how long. Yeah, I might try to make this one segment. In number 5, you have a trinomial that needs to be factored that's got a 1 in front of the squared term. That's the easy kind of factoring. So is this one, got a 1 in front of the squared term. So in those cases, let's do the bottom one first. I'm looking for two numbers whose product is the 4, that last term, and that adds to be 5. Well, those two numbers are 4 and 1. You don't need to break this up into a 4t and a 1t, but you can. I want you to know you can. But because this is a t squared, you can just go ahead and put the t in the front of each of these, a plus 4 in one of them, a plus 1 in the other. And if you just checked, I'm going to erase this, but if you just check this inner smile here and the outer smile right here, they would total to be a total of 5t. So that's what this is right here. So I know I have successfully factored the denominator. So upstairs, I need two numbers whose product is a -9. And I want those to add or sum up to be a -8. Oh, well, that's got to be 9 and 1 in some way, shape, or form. It can't be 3 and 3. One of them has to be negative. It looks like the 9 has to be negative in order for a -9 and a positive 1 to add to be a -8. So this is going to factor, the numerator is going to factor into a t minus 9 and a t plus 1. I'm going to go ahead and copy these down. So the numerator was t minus 9. The denominator was, sorry, I forgot the t, is t plus 1. I said that wrong. The numerator is right here. The denominator is the t plus 4 and the t plus 1. So remember, you must factor everything first, and then if there is a common binomial factor, you can remove the factor, but not right here. T minus 9 over t plus 4 is your answer. You cannot cross those t's off. They were binomials. They have to be identical in order to remove them. So don't be taking those out. All right, this numerator is called the difference of squares, remember. So I can put an x in the front of each of those, a plus 1 in front of one of them, and a minus 1 in front of the other. Remember that when there's a 2 in front of the x squared term, I'm going to go ahead and do this long route. So I'm looking for two numbers whose product is a -2, and I want the sum, I want it to add up to be a -1. So it's going to have to be 2 and 1, but one of the signs will have to be negative. Looks to me like the 2 will have to be negative in order for those to add to be a -1. So we come over here and we replace this minus 1x with a minus 2x and a positive 1x. Isn't that the minus 1x? Bring down this minus 1, bring down the 2x squared. I won't be able to do this all the time, but then I'm going to group the first two, group the last two. I'll take the greatest common factor out of these two, and that's going to be a 2x. And when I do, I'll need an x here and a minus 1 here. There is nothing you can take out of these, so you have to show yourself taking out a 1. And oh joy, oh good, these are supposed to match. They do. And then the 2x and the plus 1 go in the other binomial. That is going to be what I'm going to put up here. I'm going to have an x minus 1 and a 2x plus 1. So I factored both the numerator and the denominator. I'm hoping that there is a common binomial factor, one that's on top and one that's on the bottom, that is the same. And my final answer to this problem is going to be in the numerator, the binomial x plus 1, and in the denominator the binomial 2x plus 1. If you keep those parentheses around it, you'll probably not want to try to cross off these x's and these 1's because they have to be identical before you can cross them off. Okay, let's go I think we have time to do a few more. So this is the difference of squares, and it's going to factor such that there's going to be a 5 in the front of each of these, a plus p in the back of one of them, and a minus p in the other. Downstairs, this is an easy problem. It's got a 1 in front of the p squared term. The two numbers that multiply to be 25 and add to be 10 are very easy. This is called a perfect square trinomial. They are 5 and 5. So this p squared plus 10p plus 25 factors into p plus 5 and p plus 5. So this right here, p plus 5, that's what it is. It's p plus 5, even though it's written as 5 plus p. Addition can be written in any order, and that cancel out. So what you're left with in this problem is in the numerator 5 minus p, and in the denominator p plus 5. Don't be canceling those out. Those are not identical. They nowhere, shape, or form have the same signs. Now here in number 8, when you have an x minus 5 and a 5 minus x, would you just notice that these are interchanged in the denominator, both with this minus sign? So one thing you can think of is you can think of taking out a negative 1 out of this expression. Well, if you did, you'd need a negative x here, because a negative times a negative would give you the positive x. And you need a positive 5 here, so because a negative times a positive, that minus 5. And downstairs, you have 5 minus x. We'll see this negative x plus 5. It is 5 minus x. And again, you have downstairs 5 minus x, but you factored a negative 1 out of this problem. So I get to remove these, but the bottom line is when you see a problem like this where the binomials are the same, but the terms are in opposite positions, they are equal to a negative 1, and I don't go through all the work to solve that problem. So see this one right here? I just call that negative 1. I don't go through all the work. I don't factor this into x minus y and x plus y, and this into y minus x and y plus x. And so look at this one. The 6 minus 5a, nothing can be factored out of it. But downstairs, a 2 can be factored out. Now, if you wanted to factor out a negative 2 right now, you could. And then this would be a negative 5a. And then this would be a positive 6. And this negative 5a, this 6 and this 6, they would cancel out. Please remember, when you cancel something out, you're left with a 1. And so what I have is a 1 divided by a negative 2, or I can put the sign in front of the fraction, negative 1 divided by 2. This next one I'm not going to do right now, but basically it says, if you, like I did for a previous problem, if you decided to put 2 and 3 into this problem and evaluate it, and I am going to tell you that when you do that, you should get, when you put a 2 in here for x and a 3 in for y, anywhere you see the x, and the y's, when it reduces, you get 11 over 8. I will tell you that this numerator factors into 2x minus y and x plus 3y. That's what the numerator factors into. This denominator factors into 2x minus y and x plus 2y. So when you're done with this problem, these will cancel out, and you will have simplified this to read x plus 3y over x plus 2y. When you substitute in to this final expression a 2 for x and a 3 for y, you will get 11 in the numerator, and a 2 for x and a 3 for y, you'll get 8 in the denominator, just like you would have done if you substituted it into the original expression. I'm going to stop. That was a pretty long segment. This is simplifying algebraic expressions by factoring first and crossing off common factors.